Hello.
Uh, Good evening, sir.
Yeah, good evening. Uh, okay. So today we'll start our discussion of geometry. So first of all, there are certain things that you need to know. Uh, we are going to assume some basic knowledge of geometry. The basic stuff that I am going to assume is your standard results on similarity, congruency, the things that you have learned in standard 9 and 10. So I hope that is familiar to everyone. That much you know, right?
Yeah.
So basic
Yes, sir.
similar triangles, congruent triangles, standard stuff about quadrilaterals. So that I'm going to assume. Also, you have to make sure that you do your geometry in a different notebook. Keep a separate notebook for geometry for everything that you're going to do in these classes, and make sure that you write it properly so that you can revise it. It should not be in such a way that later you cannot understand what you have done, right?
Okay, sir.
So make sure of that everything that we do in these classes, you keep it in such a way that you can revise it before your exam towards the end of the year.
Okay, sir.
Then the first thing that we'll start off with is angle chasing. So the idea here is we will be trying to find different angles in various geometric figures, and we are going to learn how to apply angle chasing and figure out geometric problems and solve them. So we are going to see different situations where angle chasing is going to be useful, and you will find that so many Olympiad problems will find that can be solved to a large extent by simply looking at angles. So this section of the course will go on for at least 3 weeks. So the next 2, 3 weeks, we're going to do this. And then after that, we are going to learn some advanced properties, advanced geometry, which will involve some lemmas that you might not be familiar with, that might be new. And after that, there is something called complex numbers and applications in geometry, complex numbers in geometry, and something called point geometry that I want to discuss. So all of these three things are slightly advanced, and these are techniques that we will learn. This is theory, and we learn all of it through problems. Do it through problems and basically try to apply it in Olympiad problems. So those things will happen probably next month. This month is about understanding basic geometry and getting comfortable with angle chasing. Again, we are going to do it through problems.
So, sir, would you please no, not take class or in very similar days for boards exam, right?
When is your board exams?
15th, 20th, 25th, and then 1st, 8th, and 13th.
From
Like,
February, right?
yeah, yeah,
Sir,
15th February to what date? Last date?
18th March. But you can take between that, but not like 1 to 2 days like before exam. Yeah, but only this only. 1 days before exam.
That's
इतने
fine.
मत लीजिए.
We will schedule it accordingly, which is in the gaps and all. So
Yes,
many
sir.
people will have similar days, right? Because
मेरा तो 17th से स्टार्ट है, फिर 23rd को खत्म, फेब में
which board is yours?
ही स्टेट बोर्ड बिहार.
And the other ones are CBSE, right? Aniket?
Yes, sir.
Yes, sir.
So depends on the dates and all, we can decide and schedule classes accordingly. That should not be a problem. So that will adjust whatever is required. But the classes won't stop. They might become less frequent during your board exams. So we will continue doing geometry probably till after your boards, but by then, end of March is the target to finish this. March end.
Okay, sir.
Because there will be some fewer classes in February and March, but mainly the target is to finish it by March end. And by then, you should know enough to easily handle whatever you will see in RMO, INMO, and all. So that much level we should have by then. So again, we are going to start with angle chasing and we are going to learn everything through problems. There will not be like a lot of theory discussions. The basic geometry that we'll cover in angle chasing, most of you already know. And if you don't know something, we'll be proving it in class through some problems. So make sure that you make good notes. If you don't make notes, all of it will be useless because you'll forget it by May, June. Do you understand what I'm saying?
Yes.
Yes, sir.
So if you make good notes, you can revise it and everything will be great and you'll improve a lot. After today's class, I will share the worksheet by tomorrow latest and you can work on the problems there. So we'll start off with this first problem.
Sir, you
And
have given one sheet of 100 questions. What is it for? Means geometry basics, or when we should do that one?
you have to attend the sessions to actually know what it is it for. So I'm not going to answer that question. If you have not attended any session, you need to watch the YouTube playlist and find out what is this sheet for. The classes have been going on for a month. If you don't know what the sheet is for, nobody can help you.
No, sir, you have sent one sheet at first of 100 questions of geometry.
Yes.
So that is means when we should do that one? After.
Whenever you can do it. It's not very easy. You need to try to do it. If you can do it, do it. When you should do it, matlab? Whenever you can. I thought you are referring to the last 8 weeks of classes, 4 weeks of classes that we have had, the
No, sir, that
sheet.
one not. Means you have sent one sheet of 100 questions at first. So we will do that one at last. That means after the geometry sessions.
You can do it whenever. Nobody is stopping you from doing it. We are not going to discuss it in class right now. Right now, there is a plan for what I want to teach. Those problems are practice problems. You can try them whenever. You understand what I'm saying?
Okay, sir.
Right now, we are going to proceed with the plan to cover all the things that need to be covered. Those questions are practice problems that you can use. However, that is not part of the theory right now. Okay, so first question is this. Let E be a point inside a square ABCD, inside a square ABCD, and let F be a point outside the square such that triangles ECB and triangles CDF are equilateral. You have to prove that points A, E, and F are collinear. Everybody knows the meaning of collinear, right?
Yes, sir.
Yep.
Collinear means they lie on the same straight line. And the usual way to prove that points are collinear is to see whether the angles that they make add up to 180 degrees. Is that clear to everyone?
Mm.
So draw a rough figure. In geometry, it is important to draw good figures. You don't need to draw the figures very exactly or precisely, but a rough figure to give you an idea is absolutely important. So make that a habit and try the problem. This should be your rough diagram, something like this.
Yes.
Yes, sir.
Hmm. You have to prove that A, E, F are on the same straight line. Anybody who has gotten the answer should let me know what they have done. If they have gotten something, tell me.
Yes, sir.
Tell me. Okay, wait for a moment. Let other people also try it. Okay,
Okay.
Anant, you can't tell. Somebody else has to say.
Okay.
I will write the second question for you then. So you should try to prove this one.
Hmm.
Anybody else about this question, collinearity? You have to realize that ABCD is a square and these are equilateral triangles. So how would you prove collinearity? Tell me, anyone?
Angle FEA being 180.
Right. So you have to try to show that this angle plus this angle plus this angle is 180. So all
Yep.
you need to find is all three angles, right?
Yes.
For the other people, why are you not able to find the angles? It's not so difficult.
Sir, done, sir.
Okay, other than Aniket, who else? Nobody is able to find the angles. It is obvious that this angle is 60 degree because it's equilateral triangle. What else can you figure out? What you can do is this is a square, so AB length should be same as BC length, should be same as BE length, right? Does everyone realize that this side has the same length as this and therefore with this, so triangle EBA is isosceles.
Yes, sir.
If triangle EBA is isosceles, then this angle will be equal to this angle, right? And you should see in this isosceles triangle, I know this angle is 60, so this angle is 30, right? If this angle is
Yes.
30, then this will be 150 by 275 and 75, right?
Yeah.
So we know this angle is 75, we know this angle is 60. We just need to find out this angle. Again, we can see that this is isosceles with this, right? Correct?
Yes.
And this much was 30 and this much was 60 because it is equilateral. So this is 90. So we get 45, 45 here. I hope it is obvious to everyone right now. It is 45 degree
sir.
plus 60 degree plus 75 degree, which adds up to 180, and therefore it is collinear. The points are collinear. Is everyone following what I am saying? The other
Yes.
people who are not saying anything.
Sir, can you explain how did you get them as isosceles?
Because we said that ABCD was a square, right?
Okay,
So this is equal to this.
okay, sir.
And wasn't it an equilateral triangle inside a square?
Yes, sir.
So this is equal to this and this.
Yes,
So what is this triangle? This triangle.
isosceles.
Similarly, this side is equal to this side is equal to this side, right?
Yes, sir.
So this triangle is also isosceles.
Got it.
Is anyone else having any problem with this?
No, sir.
Okay, so then nobody has a problem. Then try the second one. A triangle is right angled if and only if the median on one side is half of that side. So you have to prove both sides of this theorem. The first side is you can prove that if the median on one side is half of the other side. So make a triangle and draw a median. Let's say we have a triangle like this. This is A, this is B, this is C. From A, let's draw a median. And this is M. And let's assume that AM is equal to half of BC. We are making the assumption that the median What is a median? Median is a line from a vertex to the opposite midpoint, opposite side's midpoint. So this is equal to this, and we are assuming that AM is equal to half of that side. Now we have to prove that triangle is right angle. Is everyone understanding the question?
Yes, yes, sir.
So try it out. Think about it. Half of BC, by definition, half of BC is BM, right? BM and MC, right? What we have been given is that AM is equal to half of BC. So actually, this is also equal to this is also equal to this, right? Is that understood? Is everyone understanding that?
Yes, sir.
Two isosceles triangles.
Huh? What?
Two isosceles triangles.
Yes, they are isosceles, but I don't know if that helps us prove it. Maybe it does. You should try it out. Yeah, it does help us prove it. There are two ways to prove it now. One way is by doing isosceles triangles. You can say that this angle is x, this angle is x, right? So this angle is 180 minus 2x. And you can say that this angle is y and this angle is y, right? So this angle is what? 180 minus 2y. Correct?
Yes.
So after that, you can say 180 minus 2y plus 180 minus 2x should add up to 180, right?
Yes, sir.
So from here, it will come that x plus y is equal to 90 degrees.
Okay.
Correct? So another way to do it, like now without using this isosceles triangle stuff, can you find another way to do it?
फाइंडिंग ये तो हो गया था दूसरा सोच रहा हूँ फिर
There is another way to do it also without thinking of isosceles triangles.
See, sir, either we have to prove like that aim means if we draw a perpendicular from A to BC, so means then we have to prove that aim is a point, aim is the only point that it's perpendicular like that.
No, M is the endpoint of a median. It doesn't have to be perpendicular. M is the endpoint of a median. No, why will it be perpendicular?
Sir, can we use Pythagoras theorem?
How? We don't know if it is right angled. We have to prove that it is right angled, right?
Okay.
I mean, you can use the converse of Pythagoras if you can, but you don't know this side, no? You know x, x, y, y. No, x, 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 right?
Yes, sir.
But I don't think that tells us anything about this side and this side, right? Do you understand what I'm saying right now?
Yes, sir.
We don't know enough side information to use converse of Pythagoras theorem. We cannot use direct Pythagoras because we have to prove it is right angle, right?
Yes, sir.
Think in terms of triangle centers. You know what I mean by triangle centers?
It is a property of a circle.
Circumcenter.
Right. What is special about this point M?
It is equal from both all 3 points of the triangle.
all three sides
Not sides.
Vertex.
y vertex
वही नहीं है, it's different है.
हाँ मतलब सॉरी सर
M is equidistant from all the 3 vertices, right? So it must
Yes,
be
sir.
the circumcenter, right? Is
Yes.
everyone understanding that? So basically we can draw a circle like this, which passes through A, B, and C, correct?
Yes.
And the center of that circle will be M, right? Correct.
Yes.
And what is the radius of the circle? BM, right?
BM. Yes.
Or MC.
Hmm.
So what is BC line?
Diameter. Diameter.
What is angle in a
So,
circle, semicircle?
90
semicircle,
degrees.
90.
So because of circle properties and the fact that M is circumcenter, we know that angle in a semicircle is 90 degree. So therefore angle BAC is 90, right?
Yeah.
Okay, so that is the second proof. Now, question 3. A right angle triangle has an interior angle of 30 degrees if and only if the opposite leg is half of the hypotenuse. And you have to do this without any trigonometry. Obviously, trigonometry se to obvious hai. Everyone understands the question.
Yes, sir.
The side that is opposite to the angle is half of the hypotenuse. So we are saying that this angle is 30 degree in a right angle triangle if and only if this is half of this. And we have to do it without any trigonometry. Assume that you don't know any trigonometry.
हो गया सर.
कैसे बताओ?
सर मैंने सर मतलब इसको सोचा, फिर मैंने AC को फ्लिप कर दिया, मतलब BA की एक्सेस पे C को फ्लिप कर दिया.
Basically, you're reflecting it C about the AB line.
हाँ. Yes, sir.
So you'll get a point D, right?
हाँ.
And these two triangles will be congruent.
Congruent. Yes, sir.
This will be
तो
30.
yes, sir.
And then what? This side
सर
length
जब
is
वो
equal to
60 हो
this.
गया तो नहीं, ये 60 हो गया एंगल CAD. एंड हमें एंगल चेजिंग से पता है कि एंगल BCAB 60 है. हाँ, तो इक्विलेटरल ट्रायंगल हो गया सर. मतलब
Right,
CB इज ट्वाइस ऑफ AC बाय कॉन्ग्रुएंसी.
right.
ठीक है.
So we are getting that CB is twice of AC by congruency. Congruency
नहीं
से
नहीं
कैसे?
नहीं, हमने कॉन्ग्रुएंसी से प्रूव किया कि AC इज इक्वल्स टू AD, एंड फिर
Right,
CD इज इक्वल्स टू 2AC, और CD CB के बराबर भी था, इसलिए CB इज इक्वल्स टू 2AC.
right. So basically we have flipped it like this and we are getting two congruent triangles and we are getting that the whole thing is equilateral because 60, 60 and 60. And because it is equilateral, now I know that CD is equal to BC and that is twice of AC. Is everyone understanding what is happening?
Yes. Yes.
I hope everyone else also has understood, all of you.
Yes, sir.
So we are not using the sine. Obviously, it is obvious because of sine 30 degree also, but we are seeing a pure geometric proof where we do a reflection of C around AB mirror. And if you do that reflection, then automatically you are able to see that it's equilateral. Okay. Fourth one. In an isosceles triangle, the obtuse angle formed by the bisectors of the equal angles is equal to 5 times the third angle. The unequal angle, by the way. Find the angles of the triangle. Not very difficult. Everybody should be able to do it.
An isosceles triangle. Okay. The obtuse angle formed by bisectors of equal angle.
Why are you reading
Bisectors.
it out loud?
Oh, sorry. I
You're
thought my
not on
mic is
mute.
off.
Hmm.
Sir, is it 20 degrees and 40 degrees?
20 degrees and
1 second.
how can it be
40 degrees.
40? What do you mean? 20 and 40. How is this isosceles triangle?
1 second, sir. 1 second. Oh, sir, 20 degrees and 80 degrees. And 80.
Okay, that is the answer. This should not be a problem for anyone. I hope
Yes, sir.
everyone is getting it. You just have to draw the figure and write the condition of the problem. The equation that you will get is 180 minus b by 2 minus c by 2 is equal to basically 5 times angle A,
Sir,
right?
it's coming 80, 50, 50.
No,
80, 80, 20, sorry.
80, 80, 20 is the right answer.
Yeah, yes.
And B and C are equal, so it will be solved immediately. Okay, question 5. Triangle ABC is isosceles. Angle BAC is greater than 90 degrees. The perpendicular bisector of side AB cuts BC at D, and perpendicular bisector of AC cuts BC at E. First thing you have to do is prove that AD is equal to AE, and second thing is, if BD is equal to DE is equal to EC, find the angles of the triangle ABC. Okay. By the way, the triangle ABC is isosceles, so AB is equal to AC, you can assume.
Okay, isosceles. Yes, sir. So then it's proved, sir.
How? Tell me.
The first one.
How?
Sir, if I didn't notice it for isosceles, if it is isosceles, angle ABC is equals to angle ACB.
Mhm.
Yes, sir. And sir, I just connected DA and EA. Yes, sir.
Then
And sir, since angle B, I took that जो परपेंडिकुलर बाइसेक्टर है AB पे वो M लिया है सर मैंने उसको मतलब कोई
this point.
यस सर एंड उसको L लिया है तो सर BMD इज कॉन्ग्रुएंट टू DMA मतलब BMD इज कॉन्ग्रुएंट टू AMD
Mhm.
सर बाय RHS
Right.
सर सिमिलरली ALE is congruent to CLE by RHS
Mm-hmm.
and sir since angle ABD is equals to angle ACE and similarly angle DAB is equals to angle EAC
Right.
sir and these angles are equal then the congruent 90 degrees also there sir
What are you saying? What is your
तो मैं आपको एक
statement?
बार लिख के भेज रहा हूँ सर
लिख के
बोलने में नहीं
भेजो,
आ रहा
यहाँ
ये
पे
बात
बोलो क्या हो रहा है.
सर एक मिनट सर बता रहा हूँ सर
We have BD is equal to AD and we also have CE is equal to AE, right?
हाँ यस सर
We can prove that triangle ABD and triangle ACE,
ACD is
they are
congruent
congruent.
yes sir
Why? Because first of all, so many angles are same. They're similar, obviously.
एंड ऑब्ट्यूज भी है सर उसके साइड्स भी इक्वल है फिर
First of all, they are similar, right?
हाँ यस मतलब वही लिख लिया था सर वो बोल नहीं पा रहा था यस सर
They are similar first because two angles are same,
इक्वल यस सर
and they are congruent because two sides are also
सर
equal.
सेम यस sir that's why
So if two side triangles are similar and one side is
हाँ
common, then obviously it is going to be congruent.
yes sir
So if this is congruent to this, you can say that BD
that
is equal to EC,
and
right?
sir yes sir and then AD is equals to AE
Because we already know BD is equal to AD and CE is equal to AE,
yes sir
right?
hmm
So it's about understanding the
now we can
properties
prove
of
sir
hmm,
now we can prove MD is equals to LE but
right, but
it's
we
not
don't need
asking that
to,
we don't need to we only just need AD and E so first is done sir
right?
Or is there another way? Sir, I found another way.
But
Sir, in triangle BMD and triangle CLE,
mm-hmm,
we can say both of them are congruent
right.
due to AS. So therefore we can say um, side MD is equal to side LE.
Mm-hmm.
So in AMD and ALE, those two triangles we can say they are congruent due to SAS,
Mm.
and then therefore AD is equal to AE.
Basically, it's same only. We did the big triangle, you are doing small triangles, right?
Yeah, but then it becomes a little easier for me.
Fine. Second part of the question.
Sir, 30 degrees, and 120 degrees.
What are the angles?
30, 30, and 120.
How?
Sir, by uh, because BD is equals to AD, the triangle is A is equals to BC. That also triangle has to triangle ADE is equilateral. So the integer angles are 60 degrees, and then by angle chasing.
If BD and DE and EC are same, we already know BD and CE are same. So if it is also equal to DE, then we will get that in this triangle, all three sides are equal, which means it is equilateral. So it is 60, 60, 60. And then this angle is 120, and this triangle was isosceles. So the remaining angles have to be 30 and 30. And here, similarly, this angle is 120. So the remaining angles have to be 30 and 30. So the angles of the triangle become 60 plus 30 plus 30, 120 at the top and 30 and 30 here. Is it clear to everyone? I hope you all are getting this 30, 30, 120 for second part.
Yeah.
Okay. Next question is, let ABC be an isosceles triangle with AB equal to AC and angle BAC is equal to 72 degrees. On the side AB, take the points D and E such that angle ACD is equal to angle DCE is equal to angle ECB, and let F belong to the line segment BC so that EF is the bisector of angle BEC, is the bisector of angle BEC. First part is prove that triangles AFB and CFE are congruent. And second part is prove that AF is perpendicular to CE. Write down the question carefully and then think about it.
सर वो F belongs to BC है, मतलब F BC पे है.
F is a point on BC.
Okay sir.
First, figure out some angles. For example, if the top angle overall was 72, the angles here are 54 and 54 total, right?
Yes, sir.
Sir, what is that F point? Let F belongs to what is that?
अभी तक you have not figured out that only. F is on BC. We have already said that before.
I was just doing the question, so I'm not.
Why are you not seeing the diagram? I have already made the diagram 5 minutes ago, and Aniket had already asked this. Why are you unable to see that?
Sir, I have taken the screenshot of the question and I'm just trying to solve that. With the figure and the.
You cannot see the screen. Why do you have to take screenshot? Can you see the screen right now?
Yes, sir.
These angles are 54, 54. These angles are trisection, so it will be 18 degree everywhere,
1880.
right? So if you think about it, this angle total is 36, right? And this angle total is 72. So this angle is also 72 then, right?
Yes, sir.
Which means the triangle ACE is isosceles, right?
Yes, sir.
Which means AC is equal to CE, correct? Now, angle BEC, what will be that angle? 72 is on this side, so 108 is on this side, right?
110, 110.
108 by 10 कहाँ से आ रहा है?
Oh, yeah.
108, no.
Yes,
And
exactly.
then
Yes.
EF is a bisector, so what is half of this? This much is 54 then,
Yes.
which means the triangle EBF is also isosceles, right? Which means EF is going to be equal to BF, right?
Yes, sir.
Yes, sir.
Okay, great. So now if you look at the triangles that we need triangle AFB, AFB, and CFE, CFE, right? So notice those two triangles, CFE may, what are the sides?
Sir,
CF,
CF.
CE, and
Hmm.
EF, right? And what are the sides in AFB? AF,
AF, BF,
BF,
and AB.
and AB.
और सर वो isosceles triangle है तो फिर
We already know that C, यहाँ पे this is EF and BF are same, right?
yes, sir. And we know that AB is
हाँ, we know AB is equal to AC.
हाँ
AB is equal to AC and AC is
AC and
equal to
AC is
CE.
equals to CE.
So we know that AB is equal to CE. So two sides are already coming, right?
And angle EFB is equals to angle
So here if you see this is 54, this is 54, so this is 72 here. And in that triangles, which triangle it was? CFE. CFE, 1 second. Oh, so this angle is 108 here then. Angle EFC is 108. And in AFB, what are the angles? AFB. So we know that this is, okay, we can just do the 54 degree angle. We can take the angle between the two common sides.
Yes, sir.
So in the AFB triangle, the two sides
That
are
is
what?
54. AB and BF.
AB and BF. So that is
Yes, sir.
54. And in the triangle CFE, between CE and EF.
CE and EF 54.
So
SAS.
SAS. First, you have to find all the angles, then you have to use the fact that there are so many isosceles triangles coming.
Yeah.
Right?
Yes, sir.
If you use both the facts, then you will get SAS congruency here.
Yes.
Now prove the second part. AF is perpendicular to CE.
हो गया सर.
How? Tell me.
Sir, finish.
How? AF is perpendicular
सर
to CE.
Sir,
सर अच्छा बोलो.
Um,
sir,
सर
angle CED is equal to 72 degrees, and we can figure that angle, what we call this, CF, and that intersection point with blank. Yeah, yes,
Let's call it T.
yes, sir. And sir, that angle is also 72. We can say that
Which angle?
sir, ETF.
How do you know ETF is 72? How
सर
can
may I
that be
tell
72? That is 90.
sir may I tell my solution?
Sir.
Okay.
Sir, since we have proved AFB is congruent
uh,
to AFE,
hmm,
uh,
AFP is congruent to
congruent to CFE.
hmm,
Now, sir, and we know angle CFE is 108 degree.
CFE is 108. Okay.
Hmm. Means angle AFB will be also 108 degree.
AFB will also be 108.
Now, sir, we know that EFB is 72 degree.
EFB. So this part is 36.
It's why 36. And we know that FET is 54. So we left with 90 degree.
Hmm.
Then we proved that.
So this angle was known. We found that congruency. We found this angle and this angle are same 108, 108. So the middle angle has to be 36.
Yes,
And 36 plus 54 is 90. So this has to be
90.
90. So it is pure angle chasing.
yeah, also we had angle EVF, so that angle AFB is 108, EVF is 54, so angle EAT is 18. So in triangle ETA, 72 plus 18, then ETA is 90.
Hmm.
So there are many ways. The point
Yeah,
is angle chasing is giving us the proof, right?
yeah.
Okay. What I'll be doing is I will be sharing a problem set. The problems will become progressively harder. Obviously, it will not be so easy all the time. So try the questions in the problem set that I will share by tomorrow. I'll share it, and we'll continue from this point.
Yes,
So
sir.
we'll try to do it as fast as possible, but obviously, like we have to make sure that all the theorems that we need will slowly learn. So,
Sir, how much time will you suggest on each problem?
however much it takes to. These are
Okay.
right now, there is no time limit to Olympiad problems. You can try it for as long as it takes, but the problems that I am sending are not so tough right now.
Means according to you, how much you
It should be done less than half an hour.
each problem?
Obviously, some problems will be done in 10 minutes or 5 minutes, but should not take more than half an hour. Each problem will not take half an hour to do. अभी जो हम लोग ने 6 problems किए हैं ना 1 घंटे में,
Hmm.
it could
Yes,
have
sir.
been more also. We are discussing, that's why it is taking so that much time.
Yes.
But normally when you do it yourself, it should be 10-15 minutes, maximum half an hour it should take, but it should not be more than that. Right?
Okay, sir. Yes, sir.
So try the problem set that I will share, and we'll continue our discussion in the next class from this point.
Yes, sir.
Okay, that's all for now then.
Thank you, sir.
See you
Good
next
evening.
time. Bye.
Okay, so
Thank you.
Okay.